Well, good morning everyone. Welcome back to my YouTube channel. Presenting before you this wonderful tutorial is Harmonic, your mentor. To those of you that are new, make sure that you subscribe and you also hit the like button, and also don't forget to share. So we have a very interesting question on simple harmonic motion, and the question, of course, it's here, you're able to read. But then let's get into our usual business in finding this question. So we have the data, of course, here. I've already highlighted the data, and the only thing that we have to do is simply to find this question. So the first question is asking us to find the spring constant K. Okay, so remember this formula. If you want to find the spring constant K, then you're supposed to relate its velocity together with the spring constant K, of course. Okay, so remember this formula. I think I highlighted this formula in my first video where I said that the velocity is equal to the square root of K over M, then A, this was A minus X. Okay, but then remember that our X is 0, so of course we won't put anything here. So to make K the subject of the formula, of course we'll introduce a square and a square here so that we can have V squared equal to, this is going to be K over M, then A squared, and of course we're going to have V M then equal to K A. Okay, so from here we're able to make, this is A squared, we're able to make K the subject, so it's over A and over A. And of course, if we cancel, we're going to remain with the constant K of V squared M over A over 2. So of course, our M is our mass here, our V is simply 3 meters per second, and our A is simply 0.125. That is our amplitude. Okay, the second question is asking us to calculate the energy, total energy. So total energy is given by 1 over 2 the spring constant K. Remember the units for spring constant K, it is just Newton per meter. Okay, so this is going to be A squared, where we already have our spring constant to be, our spring constant has already been found here. It's already been found here. So you replace the spring constant with the K here, then your amplitude is here, then you do your calculations, you'll be able to find your answer. We get to C. C is very simple. The only thing you have to do is simply to use this same formula. You can use this formula, A minus X. Now this time around you've been taught that your X is A over 2 is simply half of this amplitude. So this is simply A minus A over 2. So if you replace everything, if you divide this amplitude by 2, then you subtract it from the original amplitude, then you have your constant K, you have your mass, then you're able to find your velocity in meters per second. So this is just how simple this question was. Thank you so much.